Hello everyone, I am Rajesh Kumar. Today I am going to discuss about a very important topic for your semester examination as well as your competitive examinations point of view, illuminations technology. Before starting this subject, first I will introduce what is light. We know that without light we are not able to see anything, we can't do anything. So light is the most important part of our day-to-day life. Almost all human activities depend upon light. And sun is a prime natural sources of light, but absence of sunlight or in night time we also required light. At that time we are using artificial lights, and artificial lights plays almost main role in our daily life. These artificial lights are produced by mechanical lamps or electrical lamps, but due to the poor performance of electrical due to the poor performance of mechanical lamps we are using electrical lamps nowadays. And the main important role play in electrical lamp is decorative purposes, advertising of anything, traffic control system, medical fields, street lighting, etc. We are using electrical lamp systems. Some important merits of electrical lighting is that first one is the cleanness. There have no any pollutions free of lighting we are getting from electrical lamps. Second is that easy to control, just like as a switch on or off. Third is the economical way we are getting electrical lightings, that means the cheap way, easy to control, easy to handle also, no need to skillful persons to operate electrical lightings. Fifth point is that steady state output, we are getting the constant outputs. Sixth point is the better reliabilities. Seventh point is that suitable for almost all purposes. Already we talk about these things. Key electrical lighting everywhere we are using nowadays for day-to-day life purposes. Before starting the electrical method producing lights, first we will discuss about the illuminations. What is illumination? Okay. So when first I will draw it. That is, suppose that this one is the suppose source, this is the surface, this is the human eyes. So the light coming from the source and interact between the surface and reflected from the surface to reach human eyes, the complete process is called the illuminations. When light falls on a surface, it becomes visible. The phenomenon is called illuminations. Okay guys, it is defined as illuminations flux falling on a surface per unit area. It is denoted by E and measured in lumen per square meter or meter candela. That means E is equal to phi upon A, and the SI unit is lux. Okay guys, now we talk about the following methods of producing light. First method is that by developing an arc between two electrodes. Okay. So two electrodes carrying current are separated through a small distance. An arc is struck between them. This method is used in older time for street lighting purposes, but nowadays where we are required extreme brightness, that places we installed this kind of a arc based lighting schemes. Second one is that, or first one, the most commonly arc lamp used is carbon arc lamp. Second one is that, that is the carbon arc lamp, and second one is that by passing a current through a filament. It means that when an electric current is passing through a fine metallic wire, it raises the temperature of wire. At low temperature only heat is produced, but at higher temperature light radiations goes on increasing. Okay, and we know that as filament lamp consists of a fine wire of high resistive materials placed in a evacuated glass lamp. The temperature of this kind of a glass operated lamp temperature is 2500 degrees centigrade. Third part is that by electric discharging through vapors or gases. That means an electric discharge lamps required a high voltage at a starting and low voltage during operations. It means that when we have to start, suppose 450 volt is required to start, and after starting this voltage, suddenly 10 to 15 minutes, 10 to 15 minutes, the voltage falls 150 volt because of low power factor. So how to improve the power factor? By using capacitor is connected across the supply, we can enhance the power factor of this. So these are basically work like that way. Now here some important factor of lighting schemes according to the classifications based on location, requirements, purposes, or so on. So here basically 5 points are basically categorized. First one is the direct lighting. Direct lighting means that 90 to 95%, 90 to 95% of the light falls directly on the object or surface. Directly. Suppose this is the source and directly goes to the downwards. That is direct lighting schemes. And having two major problems come out when we are using direct lighting: glare, too much glare we are getting, and shadows also. Second is that indirect lighting schemes. In this type of a lighting, 90% in this type of a lighting 90 to sorry okay 90% of light is directed upward by using diffusing reflectors. Diffusing reflectors we are using, so minimize the glare as well as shadows. Okay, third type of a lighting schemes we are using semi direct lighting scheme. Semi direct lighting schemes means that 60% of light is directed downwards, downwards, and 40% of light is upward directions. So in this type of a lighting, when we are using, provides a uniform distributions of light and is best suitable for room with high ceilings. Where the ceiling length is high, that places we are using semi direct lighting schemes. Okay guys, now fourth point is that semi indirect lighting schemes. Here 60 to 90% of total light is thrown upwards to the ceiling. Okay, that means upward directions, and remaining 10% is downward direction. 10% is downward directions. Okay, and this type of lighting schemes are suitable for interior decorations purposes. Now fifth point is general lighting. This type of lighting schemes are basically those type of light where the illuminaries, shadows and reflectors which gives equal illuminations in all directions. That means this, suppose this is the source and the illuminations, that means the flux passes all direction in equally distributed. This type of in only general conditions. Now when we are talking about the some factors affected to the light schemes for designing of the lighting schemes. First part is that illuminations level. Illuminations level. What is the illuminations level? Most vital factor in deciding the number and weightage of luminaries so that we are able to see and recognize the object properly. Second part is that quality of lighting. Quality of lighting. So illuminations level, suppose we are working on offices. So offices is 100 to 400 lumens per meter square. Okay, lumens per meter square is required. Quality of lighting, like so on. So quality of lighting is that key quality of lighting, it means that illumination should not be harmful to the viewers. It should be glare free as well as shadowless and contrast free. Third part is the coefficient of utilizations. So coefficient of utilizations is that lumens reaching at the working place to the total lumens emitted by the source. Usually it varies from 0.5 to 0.8 coefficient of utilizations. Now fourth point is that depreciations factor. Depreciations factor is the factor the total flux emitted by the source and its fitting may be reduced due to the depositions of dust upon the surface. It means that suppose this is the source and the source having, or source may be like a bulb, or some dust particles are come and just like a putting here, then the glare or the brightness of this bulb becomes less. So we are not getting exactly the according to whatever the efficiency of that material, we are not getting here. This is the suppose surface or working place, we are not getting. So due to the depreciation factor, so usually we can see 0.3 to 1.6 is the range of the depreciation factor. Now last one is that a space height ratio. A space height ratio is the ratio of the space between two adjacent lamps to the vertical height of the lamps above the working plane is called a space height ratio. That is the basically horizontal distance. This, suppose this one is the one object, suppose this is the first source S1 and this is the source number 2. This is the horizontal distance between first and second source. Okay, and usually 1 to 1.5. This is the space height ratio of the two adjacent sources, and this is the horizontal distance, not in vertical distance of the two particular sources. Okay guys, thank you so much.